welcome to Thursday's edition of Cracking the Cryptic, where, yes, my voice does sound funny. I have got COVID, I'm afraid, but that is not going to stop me making videos. This is how much of a puzzle head I am. My blinding headache has improved slightly, although, as you can hear, my voice is probably worse. And I've now got a sore throat as well. So, silly COVID, you're very annoying. But what puzzle are we going to be doing today? We're going to be having a look at a puzzle called Growth by Nordy. And this has got a really short and it's a clever idea. It's basically just a killer sudoku where we have to extend each of the cages by one cell in an orthogonal direction. And that's it. So it sounds very elegant. It's got a whopping rating on Logic Masters Germany, and it's supposed to be approachable, which is probably good given the state of my voice. But before I read you the rules, I have a couple of things to say. I've got a few birthday announcements today. So Alex, I think it's your birthday. Your fiance Tom got in touch with us and said that I think you've been watching since lockdown. But anyway, I hope you have a brilliant day today, of course, with lots and lots of cake. Then Amanda Haley as well, for your husband David, got in touch and told us it's your birthday as well. So happy birthday to you, and I hope you're having a great day. Beth, it's your birthday today, and your boyfriend Joe told us this, and I think you're turning 19. And he wanted to wish you good luck with your computer science degree at Nottingham, and also hope that your further maths exam went well today. And I will echo those thoughts. I remember doing my further maths exams. Oh, they were great days. What fun we had. And then Eduardo, you're turning 41 today, I think, and you're just about to up sticks and move to the UK from Austria. I might be wrong about that, but I think that's right. And if so, we wish you all the best with your move, as well as a cake-filled birthday. Now, what else? I want to say welcome, actually. We're getting a lot of new viewers and new subscribers at the moment. One of our old videos is going a bit bananas. That video is called a Sudoku with only 2 given digits. As a result, we are getting some new viewers. So if you're new to the channel, a warm welcome, and we hope that you enjoy the ride. Many of you over the months and years have become good friends of the channel, and we try to be as welcoming as possible. And speaking of welcoming, I want to tell you about something coming up on Patreon. So if you're a patron of the channel over on Patreon, then at the start of July, we have got something really rather special for you, which is a Joseph Namer special. Joseph has constructed 12 or 13 puzzles based around the rule set equal sum lines, and those of you who know me will know that that is my favourite of all the new rule sets to come into the world of Sudoku. And Joseph has constructed a whole suite of puzzles around that constraint. And that's going to be, we think, our patron reward for July. So a massive, massive thing for us. And we're very grateful to Joseph for creating this pack. And I know I need to do the results of the competition for June's patron reward. I haven't got around to drawing it yet, I'm afraid. Hopefully you'll forgive me. But COVID does, it knocks you out a bit. It's a bit annoying. So I'm just trying to keep it brief at the moment in terms of work-filled days, and just do videos. So let's have a look at Growth by Nordy, and I'll read you the rules of this one. Normal Sudoku rules apply. Each cage must extend into an orthogonally adjacent cell so that it contains a total of 3 digits, i.e. dominoes become trominoes. So that means that cage there. Actually, that cage is quite an interesting one. Let's look at where that could extend. It could extend into any of those cells there. So it must take one of these cells. It can't take this one because that is not orthogonally connected. Orthogonal is a connection along an edge. It's not a connection at a point. So this is not an orthogonal connection to this cage, but this one is. Then what else have we got? We've got cages cannot extend into the same cell or into other cages, i.e. cages do not cages do not overlap. The small clue in the top left corner of a cage gives the sum of all 3 of the digits it contains, so that's exactly what we'd expect. So if this was the 3rd cell in this 10 cage, then those 3 digits there would sum up to 10. And then digits cannot repeat within cages, so that's totally normal rules. Let's use that as the example again. What you cannot do is that, because although this doesn't break the rules of Sudoku, it breaks the rule that says you can't repeat a digit in a cage. So we have to treat our cages in this puzzle as their extended versions for the purposes of that rule. Now, do have a go. The way to play is to click the link under the video as usual. And now I get to play. Let's get cracking. And the first thing I'm seeing here is an extended 6 cage into a third cell is going to have to be the digits 1, 2 and 3, isn't it? So one of these 3 cells is going to be the extended version of this 6 cage. And that immediately puts pressure on this 10 cage. Because once we've completed this 6 cage, let's say this was the 3rd digit, so this would be a 1, 2, 3 triple. Well, what are we going to put into this domino here? The minimum we can put in is 4, 5. And that's actually the maximum we can put in as well, because we need to add on another cell. So this cage here, well, ooh. Yeah, so this cage needs a 1 in it to make its total work. And that 1 cannot be in any of those 3 cells, because the 1 is already been hypothecated to the 6 cage. So there's a 1 in one of those 2 cages, I think, or one of these 2 cells, which is the blue 1. Oh gosh, I thought I'd broken the puzzle then, but no, I haven't. I was looking at this 6 cage thinking I've got to put a 1 in it, and no, okay. But this 6 cage is quite powerful, isn't it? Because this must be a 1, 2, 3 cage adding up to 6. But the 1 that we've got in one of these 2 cells is hypothecated to the blue cage. So once we give this a colour, all will become clear. We need to put a 1 in this cage. Well, it can't go there. There's already a 1 in purple. It can't go anywhere in box 2 because the 1 in box 2 is for the blue. So it must come down here into one of these 2 cells, and it can't be in column 4 because there's already a 1 in column 4, which is the blue 1. So that is a 1. This is a 2, 3 pair. This is green. And that's rather beautiful. So actually the first digit we got was in a box we never even looked at, which was quite surprising. Can put a 1 down here. We can what else can we do here? Can we do anything else that's particularly profound? Well, this 11 cage is under more pressure than I thought at first, because these 2 digits can't be 1, 2 or 3, so the minimum value of those is 4, 5, and they can't actually be 4, 5, because if this was a 4, 5 pair, that would break this cell. So in fact they must be a 4, 6 pair. That's the only thing they can be. And where does the 1 that then needs to accompany them go? Well, it can't go in box 2 because that 1's already for the blues, so it must go there. That's the only cell that's available. So that is a cage. And that fixes this 4 and this 5, look. And it fixes this 1. Oh, this is great. And now I can't put a 1 in those cells. So the 1 that attaches to my 6 cage must be that cell, and that becomes purple. Oh, this is very good. Now, ooh, I've got a 6, 7, 8, 9. Quadruple in box 1, and this cage, which is a 10 cage, cannot have an 8 or a 9 in it, because remember it's a 3 cell cage, so it could have 7, 1, 2 or 6, 1, 3 in it, although yes, it's got a 1 in it either way. So where does its 1 go? It can't go in this row because of this 1, and the only other orthogonal connection that's possible is there, so that is a 1. This cell's a 2 or a 3. This is a cage. We're rapidly running out of good colours to use, and now I think, to look at maybe that 12 cage, or maybe the 15 cage, I'm not sure. Oh, or actually maybe this cage, because I've just noticed I've got a 1 in a 13 cage, so the other 2 digits in this cage add up to 12, but there are 3 ways of doing that: 3, 9, 4, 8 or 5, 7. Let's have a look at this 12 cage. So this domino, well, it can't have 1, 4, 5 or 6 in it. And it must have, so it must have a 2 or a 3 in it. It can't have both, because that would break this cell. And if it had neither, then these two cells would be a minimum of 7, 8, and that's too high. So that to me, I've just noticed that can't be a 6, but that's, I think, a trifling deduction. So if it's got 2 in it, the other digit, which wouldn't therefore be able to be 3, is at least a 7. So it's a minimum of 2, 7, to which we'd have to add on a 3 in one of those two cells. Oh, but it can never, that's interesting. It can never have an 8 in it, can it? Because the moment we introduce 8 into the 12 cage, it's got to have a 1 in it, and it can't have a 1 in it because of this one. So that means that this does have a 7 in it. So but the problem with this is it could be 3, 7 with a 2 beneath it. So there is a sort of there is a dilemma here. We've either got 2, 7 with a 3 down here, or we've got 3, 7 with a 2 down here. I don't think I know. I definitely know there's a 7 in there though. So that means that's not 7. And it means that this is 8 or 9. So there's a sort of 8, 9 pair left over in row 1. And that must mean what? Right, hang on. How about this 10 cage now? Maybe this is where I should have looked first. Because this 10 cage cannot have a 1 in it anywhere. Therefore, given it's the 3 cells, once we've worked out where the other cell is, it must be 2, 3, 5. That's the only way it can work. No, okay, I thought that was going to be more helpful, but it probably isn't. Oh no, I've just noticed this 8 cage down here. Well, that's got to have a 1 in it. Once it grows, a 3-cell 8 cage has always got a 1 in it. But we don't know that it's growing upwards, so we can't use it to disambiguate where the 1 goes in the 13 cage. Right, okay. So now I'm getting into trouble, aren't I? Okay, but here's a little point. Whatever is in this dot, we know that there's we know that between these two cages, between this 6 cage and this 12 cage, the 2s and the 3s in rows 1 and 2 are used up. So that means this 15 cage can't have a 1, 2 or a 3 in it at all, and it can't have a 4 in it well. When I say it can't have a 1, 2 or 3 in it at all, actually it can't have a 1, 2 or 3 in it at all. But I was just thinking this domino cannot be 1, 2 or 3 or 4. So it's a minimum of 5, 6, which would require the extra digit to be a 4. Yes, okay, that's the point, isn't it? What is the extra digit that we're going to add on to this 15 cage? That's really lovely. And I think the point is it can't be a 1, 2 or a 3, because you can't put a 1, 2 or a 3 anywhere in this 15 cage, because 1, 2 and 3 are used in row 3, and 1, 2 and 3 are used between this 12 cage, this 6 cage, and these 1s in row 1 and 2. So the digit we are adding on to the 15 cage is a 4, which must be in one of these two cells. No, it mustn't. It's not there because there's a 4 already in here. Sorry, I should have seen that before. So I'll make this yellow. And these squares have to be a 5, 6 pair. And we know the order, again, because of this 6 here. So there must be a 6 here, a 5 here. This is no longer a 6. And I see. We're left with a 7, 8, 9 triple in box 2. And we're left with knowing that this domino must have a 5 in it by Sudoku. And the other digit is again at least a 6. No, but it's not a 6. Sorry, I just noticed that. So 1, 2, 3, 4. 5 goes in it by Sudoku because none of these cells can be a 5. 6 does not go in it. 7 does not go in it. And if 9 goes in it, you need a 1 with it. And the 1s have all been used up by a variety of other cages. So this is 5, 8. And it needs a 2 with it. And the 2 in box 3 is hypothecated up to the 12 gauge. So it's a 2 in one of... Oh, that's lovely. This is a high-class puzzle. Because now I'm going to use grey for that. But look, this 2 removes 2 from these cells. And where is the 2 now that we know exists in this 10 cage? Well, it can't go here, and it can't go here, and it can't go there. And the only orthogonal connection is there. So that's a 2. This is a cage. Now we're going to have to recycle colours. There's a 2 in one of... Oh, no. There's a 2 in one of those cells. Oh, and this 2 is seeing this cell in my 10 cage. So that must be a 3 with a 6. So that 3 bounces back here and does the 3 and the 5. Okay. So far the COVID hasn't addled my brain to the point where I'm incapable of doing anything, which is good. That cell is at least a 6. It sees 1, 2, 3 in the row and 4, 5 in the column. So that's at least a 6. This cell is at least a 4. And we've still got to add on a digit, and presumably there's no 1 available again. So this is 6, 4, 2. And where does the 2 go? Well, it's not in this box, so it must be in this box. Oh, no, and there's a 2 here, so it is there. It is here. Okay, so that's good. So this is 6, 4, 2. That is a new cage. We shall make that cage blue. These are the decisions that try us. And we shall... It's very linear, this as well, isn't it? It's been like reading a book. We've sort of started here and gone this way. I suppose then we've sort of almost, is it what, the Boostrophedron or something like that? We've sort of come back this way. But we're definitely working top to bottom here. Right. There is some Sudoku going on there. Those 2 cells have got to be 7s, 8s and 9s. And that's because this little 5 here means effectively these cells see 1, 2, 3, 4, 5 and 6. Yeah, and this is the same. That's a 7, 8 or a 9 as well by Sudoku. Look at that. So there's a 7, 8, 9 triple in this box. Right. Okay, that's absolutely gorgeous, because now I know what's in the 13 cage. And that's because the digit I've not put in this box yet is 6. Where am I going to put the 6 in this box? I can't put it in the 13 cage, because I'll have to put another 6 in it to make it add up. It'll have to be 1, 6, 6. So the 6 goes up there, and that's a 2, 6 pair. Oh, that's just beautiful. That's my favourite part of the puzzle so far. So now 4 goes there by Sudoku. So what is the digit we're adding on? Oh, we need an 8. Oh, goodness me. Okay, so we need an 8 to add on to our 13 cage, but we could get the 8 by the looks of things from here, 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 or possibly here. So that's not going to be very helpful. Okay, but we've got more 7, 8 and 9-age going on in row 4. Probably this is where we need to look next, but I'm just trying to see whether I can do anything more with Sudoku. This is 5, 7, 8 or 9. That's 5, 7, 8 or 9 as well. Okay. So these two cells are a minimum of 5, 7, which is 12. And then, but they can't be 12 because then we'd have to add a 3 onto them. And we can't. There's a 3 up here and there's a 3 here. So now they're a minimum of 5 and 8, which is 13. Oh, actually, look, you can't add a 1 onto this cage. So we're having to add a 2 onto it. And actually, I can see that's got to go there. So this is a 2, and it's a 5 and an 8. Which is nice. So that means we get a 7-9 pair here. We get a 5 in the middle by sudoku. We better colour in this cage so that we know what's going on. I'll make this green. This cell now is not an 8. We can... Oh, hang on. Oh no, okay, that's okay. I was just thinking, where does 9 go in this box? And the answer is I don't really know, but it's in one of those two cells, I think. So we can get rid of some 9s in row 2. Get rid of some 8s in row 3. 7-9 pair here in in column 3. So these cells have got to be 1, 3 and 8. Which probably does something to this 14 cage. We'll have a look at that in a moment. Let me just have a think about everything else we've got. Can we do anything else that's simple here? That cell is the same as this cell. It sees a 2 and it sees a 1, 3, 4, 5, 6. So that has got to be a 7, 8 or a 9. And that's quite a high digit in the 13 cage. Oh, actually, yes, especially as the 8 cage is going to hypothecate lots of small digits, isn't it? So, oh no, I was about to say this can't be a 9, but that's probably not true. If this was a 9, you'd have to accompany it with what? This would have to be a 1 or a 3. We know the 1 in this box is going to belong to the 8 cage, but could it be a 3? Yes, if this can be 1, 2, 5. Okay, I don't know about that. I've just realised something. I should have realised this instantly. Okay, that's me being slow. That's COVID affecting me. Look, there's a 2 at the bottom of this column. So what is the nature of this 8 cage? Well, it's 1, 3, 4. But I don't know where the other digits. There's another digit in this 8 cage in one of these 3 cells. But this is a 1, 3, 4 cage, and that does fix that this is. It fixes that this is not 9. Because in this box now, in fact, well, yeah, this cell can't be a 1 or a 3. That's the simple reason. Sorry, I was trying to see whether I could go further than that and argue about whether this could actually be an 8. Because if this is an 8, I need this to be a 1, 2, 3 or 4. And the only digit no, it can't be. Because we know that the 2 in this box is down here, so it can't be 2. And we know the 1, 3, 4 in this box belong to the 8 cage, so that's a 7. That's a 9. So this is now a 9 by sudoku. So this is 7, this is 9. Good grief. So this is 7, this is 8, this is 9, this is 8, this is 7. Wow. I was not expecting this. Now we've got... Okay, so we've got 2, 3 and 9 in this row. We've got an 8, 9 pair here. Well, now we've got 3, 6 and 7 into these cells in box 5. We can get rid of 7 from here. I don't know if we can go further than that. I have 8 here. Yes, we can. Look, 8, 5. That's all done. So the bottom of this column now is a 4, 9 pair. So yeah, okay. I hadn't been looking at this 14 cage, but this is probably the time to do that. So, if this is a 9, well, we know the other 2 digits are going to add up to 5, and there's no way, because this digit couldn't be a 1, 2, 3 or 4. It doesn't work. That's lovely. So that's a 4. That's a 9. This is not a 4. And now, so now we know the other two digits in the 14 cage are adding up to 10. Now let's just see what we've got in column 1. We've got 5, 6 and 7. So I don't think that this cell can be part of the 14 cage because these two cells can't sum to 10. This cell can't be because these two cells don't sum to 10. So I think the only way we can construct this cage is with a 3-cell sequence like that. And then we can do it if we make this 7 and we make this 3, which makes this a 1 in the corner, which gives us a 1 here and a 4 here, which gives me a 3 here. So that means I've got to add 4 on to my 8 cage to make it work, and that 4 can't be there now. So there's a 4 in one of these two cells, and it's not in the bottom row, of course. So this is 4, that's a cage. I'll make that red. Did we ever get to... No, I think I stopped looking. I need to go back and check what's going on with the 13 cage now, because this digit is incredibly under pressure. It's a 5. It's just, oh no, it is a 5. I was thinking, where do I put the 1? And I can put the 1 there and just get out of jail. Look, so that's the cage that we're looking for. These are the droids we're looking for. There we go. I watched the final Obi-Wan Kenobi yesterday, and I really enjoyed it. And that is, I think we're nearly done here. Look, we seem to be almost on the stage where we're looking at Sudoku. 7 must go in there. So this is not a 3. This square's a 6 or a 9. And this square is, oh okay, this square's a 6 or a 9 as well, which we can't resolve yet. That square's a 6, actually by Sudoku, 5, 7, looking at it, that fixes the 6 and the 9 over here. That fixes the 9, the 2 and the 3. So that fixes everything at the start, and that is the nature of the 12 cage that we were trying to locate. And we shall make that a purple cage. And, okay, and my 13 cage, which needed an 8, now gets it from here, look. So that's a cage. We'll make that one orange. And then we will, this square's a naked single, obviously, that's a 5. Let's just fill that in. We need a 3 and a 4 here, which we can do, which gives us a 3 and a 2 here. And that's the 3. And now this 4 is useful. 4 and 6, 6 and 7. 9 and 8, 5 and 7 down here is all good, isn't it? This column needs a 9 and a something, 2 I think, so we can do that. That fixes the 2 and the 8, which fixes the 8 in this box, and the only other digit we're left to place, if we haven't made a mistake, is a 6. Oh, and these two over here, 6 and 2 as well. But I just want to check that I've made all the cages. So I've got a 6 cage. No, see, look, I haven't. I'm such a wally. There we go. 5, 4, 1. That one, that one. I should check the sums as well, actually. That looks, this one's not done. Ah, yes, that's where it needs to get its 2 from. Gosh, it would be, if I'd have been solving this in a competition, I think I'd have handed it in without checking this. Okay, but everything else does seem to have 3 cells in it. That does add up to 14, yes. Sorry, COVID brain was malfunctioning there. There we go. Okay, so I think that's correct. Let's click tick. Yay! That was really nice. And my favourite bit of all was what happened in this box where we worked out that this couldn't be a 166 pair. That was just brilliant. Loved it, Nordy. And exactly what I needed. Something not overly taxing today. Thanks for watching. We'll be back later with another edition of Cracking the Cryptic.